Alright, welcome to Unit 5. This is Section 1. Unit 5 is all about scale drawings and scale factor and scales and stuff like that. And Section 1 is scale drawings. And in this section you should be able to draw a scaled figure on a grid paper given a scale factor. Right? So what is a scale model? Well, a scale model is a smaller as a drawing or as a model drawing, or a smaller figure based upon a ratio is a drawing, or a figure F-I-G-U-R-E, or a figure with ratio sized dimensions to the actual object it represents. Represents. So a good example of this is like a map or a globe, right? Where we have a small stadium that represents like the large stadium, right? That shows what it's going to look like when it's blown up to the actual scale. Okay, a corresponding part is like the piece of that model is like the part or piece of the drawing or model that represents the figure of the whole right? So like we have like the figure of Alaska on a map. It looks like the shape of Alaska. It's obviously not the same. It's not actually the same size of Alaska, right? But it is the same shape of Alaska on a map. And then a scale factor. A scale factor is the fraction or multiple that the part is multiplied by it, or is sized to, right? So like a 3-to-1 ratio, like on a map, like is like 3 parts. 1 inch on a map is 3 miles, right? So that's what you have to multiply by to get the actual size. Okay, so here's an example, right? We have a figure model, scale model of this TV, and it's 3 inches to 12 inches, right? And a 5 inch to 20 inches, right? So we can say this is a similar size. This is a similar size because this is the short end of our rectangle. This is the short end of our rectangle. And then we have a long side of a rectangle, and this is the similar side of the rectangle. These are similar rectangles, okay? So like this is a 3 to 12 ratio. This is a 5 to 20 ratio, excuse me. This is a 5 to 20 ratio. So either way I look at it, it reduces to 1/4, or if I did it the other way, or it would be a 4-to-1 ratio. So how do I use this ratio? Well, it depends on whether I'm growing. This is my small ratio. This is my small figure. This is my large figure. Right? Am I going to grow it or am I going to shrink it, depending on which way I'm going? Right? What's the scale factor from going from my small, which is my figure M, this is my small one, and then figure N is my large one. Right? So I'm going from a small to a large, so I'm going to grow it. Right? So if my scale factor is greater than 1, right, it's gonna grow my object. My object is gonna get object gets bigger. If my scale factor is less than 1, whoops, I didn't let the 1, is greater than 1, the object gets bigger. If my object is less than 1, the object gets smaller. This is a shrink. This is a grow. Right? So this is going from small to large. This is a growth. Right? So I have to use the larger, I have to use the scale factor that is greater than 1. Therefore, I'm going to be using my 4 scale factor. Okay? So what's the perimeter of the scale model? The scale model is 3 times, this is 3, this is 5, so this is 3 and 3 is 6, 5 and 5 is 10, this is a 16. So the TV is going to be, it's a 4-to-1 ratio, right? So 16 feet times 4 equals whatever 16 times 4 is, so 16 times 4 is 64 feet. Okay, so what is the ratio of her TV? Well, it's a 4-to-1 ratio, right? Because it's a the perimeter of the scale. Actually, it's a 1-to-4 ratio. Excuse me, it's a 1-to-4 ratio, right? Because it's a scale. This is the scale to the actual. It's a scale to actual. A-C-T-U-L-E. Actual. Scale to actual. It's a 1-to-4 ratio, or a 1-to-4 ratio. Okay, so that's how you kind of look at all that stuff. All right, so if we look at the next example, we have these 2 figures, right? This one figure S, one figure T, and if you looked at this, it's a little deceiving, but if I take this and I kind of swing it up to here, right? This is 3 over, right? And it would just kind of get displaced to this, right? And if I look at this and I swing it up to here, this is just a square, right, on both sides, right? But that's neither here nor there, okay? But I look at the scale factor of this to this, right? This is a 1, 2, 3, 4, 5, 6, 7, 8, 9. Now look at this bottom part. This is 1, 2, 3. So this is a 9 to a 3, right? So this similar part to this similar part is a 9-to-3 ratio, or a 3. If I look at this part, 1, 2, 3, 4, 5, 6 to 1, 2, this is a 6 to a 2, which is a 6 to a 2. Sorry, a 6 to a 2. 6 to 2 ratio. So that's also a 3, right? So my figure S is a 6. So this is a 3 to 1 ratio. Okay, so the scale factor go from my big to my small. S is big to small is a 3 to 1 ratio, or a 3 to 1, right? Or it's going to make it smaller, right? So it's going to be a 1/3 ratio. This is a shrink. It's going to be a shrink. Okay. What's the estimated perimeter of S? Well, this is 9, so this is 9. This is 3 this way, so this is 9. So 9 times 4 is 36. Okay, so going from 36, divide that by 3. 36 divided by 3, you got it, is 12 feet. I guess this is, if this is feet, this is 12 units, whatever that is. Okay, so that's how you do this here. All right, so it should be noted that this is a linear, perimeter is a linear unit. So lost my train of thought. The perimeter final equals the perimeter initial times my scale factor to the first. Perimeter, the units are to the first, right? So feet to the first, meters to the first, right? Centimeters to the first, right? They're just centimeters to the first. We'll get to that a little bit more in the next section. Okay? So if all I had was my scale factor, right? And I knew that my initial was 36, and I knew that my scale factor was 1/3, I would say that my perimeter final equals my perimeter initial times my scale factor to the first. It would be my perimeter final equals my perimeter initial, which was 36 to the 1/3, which equals 12. So that's 36 to the 1/3. And this is a unit list, so it's just 12 units to the first. Okay, so there you go. We'll get to that a little bit more in detail in the next one.